Hey everyone, welcome back to the YouTube channel. As I promised, we will be starting out the series. So, today is the day two. Uh, Obviously, day one actually for the coding because yesterday we just talked about myself how the series will be working. So, today is day two, and today we'll be solving a coding problem, and this problem is a Fibonacci number problem. Although when I came here for coding, there was one problem. Like there was some pre-terms. Like if we talk about mechanical engineering, just for an example, so mechanical engineers should know what is gear, what is pistol, and all those things. Same in the coding also, there are some terminologies or we can say specific things which we need to learn. So I will be covering all those things in the beginning so that we will not face any problem when we go further. Some of them are like today we'll be solving a Fibonacci number. If someone doesn't know about Fibonacci number, and if in the interview he gets the question related to that, he might learn about this from the test cases or from somewhere else. But still, the thing is, you need to know about the terminologies. What is Fibonacci number? What is palindrome? What is factorial and all those things. So we will be covering of those things in our first week, so that we can't say these as basics because I will not be teaching you what is how can we take input and all, but we will be solving this problem. So that's how the motto of this series, level up series, has been kept. So we will be solving the problems directly instead of just relating the basics and all. Although these are basics of getting into the competitive programming, we can say. So now let's solve those out and let's understand what is Fibonacci number. So for that, let me tell you the brief or the problem statement or the question how it will be coming in the LeetCode. Although many of you might never solve a problem in LeetCode, so we will be solving it in an online compiler. So it is just a platform which all of you can go, just install library and let's get started with it. It will be easier for you. But still, for the understanding purpose, now let's understand what is the Fibonacci number. So here is the question statement which we have. So now let me tell you in our whiteboard only. So I'll take a screenshot of it and example of it and level up series. And this is our week one. In week one also we are actually solving this problem. So this is question number first. So now let's understand how this full series will be, how this question works, or what is this Fibonacci number term, and how to solve this problem. But as I have said, uh, in competitive programming, there is no language specific thing. You can solve it in any of the programming languages, coding languages. But the thing is, the main thing is the approach, the logic, the understanding of the question, on which most of the interviewers take take your will going to take your interview. So now let's get started. What is Fibonacci number? Okay, so they have given a brief about Fibonacci number, but you need to learn, or I think you need to just understand what is Fibonacci number from the beginning only, so that if in a question you directly get Fibonacci number of these numbers or something like that, then even if the statement is not given to you, then also you should be able to solve those. So now let's get into it. So Fibonacci number. It is commonly denoted by f of n from a sequence called Fibonacci sequence. Okay, these are not for your details, but see the term which they have written here, such that each number is the sum of two preceding ones starting from 0 and 1. Now, what they are saying is a Fibonacci number is a number which is the sum of preceding ones. Preceding means if we have number x, then then it like Fibonacci number will be like sum of these preceding ones. So means x minus 1 plus x minus 2. That's how the structure of a Fibonacci number is designed. So these are terminologies. So you need to understand there is nothing like a specific thing which we have to understand or something like that. Fibonacci number, okay. It is such that each number is the sum of the preceding ones. So that will be considered as a Fibonacci number. So if we get into the answer, like problem statement, these two are solved ones. But now we have to, if we have to understand it from the beginning. So now let's do the dry run, like how it will be structured. But before dry run, let's see the example number one. If n is given as 2, and also there is one base case which we forgot to discuss, that is 0 and 1. So at 0 and 1, we will get stopped. We will not go beyond this. Like if number 0, then we will go 0 minus 1, 0 minus 2. No, we will not do that. And same for 1. So 0 and 1, we can say these are the limits before and beyond, like not beyond that. Before that, we will not going to go. Now n equals to 2. So this is the first one. So now let's apply the formula. Just simple. Take it in this way only, like going here. Then going for x minus 1, or we can say n. Let me erase this first. Yeah. So it will be n minus 1 plus n minus 2. Okay. So here it is. So if we go in this way, is it possible? Yeah. So we will reach here at 1, we will reach here at 0, and then we have to stop our operation for sure. So that's how it is done. And now we have to just find the sum of it. Sum of it, we will get 1. That will be our answer. So bit simpler. Yeah. Now let's get into bit more in depth. For 3 also, if we take, so it will be like if our n is equals to 3, in that case, we will be applying the same thing, making branches of it, n minus 1, n minus 2. The base case, if I have to write as base case, is reaching 0 or 1. Now what will happen? N minus 2, it will get us to 1. So we will stop here. But in this case, it will be reaching 2. So now again we have to do Fibonacci number. So Fibonacci of 2, we have already, although understood it is 1, but still we have to solve it here. So this will be a new statement. So we can say n base to 2. So here, but we will be doing n base to 2 minus 1, n base to 2 minus 2. So here we will reach 0. Here we will be reaching 1. Now we have to sum both of them. It will for sure get us to 1. Now summing up both of them, so 1 plus 1, it comes out to be 2. That will be our answer. So that's how it is done. Now let's solve a problem, or we can say an example which is not written here. So it will be if just suppose we got n equals to 4. Now what we have to do is we have to find Fibonacci of it, just doing the same or following the same process. N minus 2, n minus 1. So n minus 1 will be giving us as answer as 3. It will be giving us 2. Doing it again, it will be giving us like n minus 2, and then again n minus 1. So it will be giving us 2. It will be giving us 1. So we will apply a stop here. Apply a stop. Done. 2 is here. We will go to this, and we will go to this. How we went there? So it is just like applying same thing. N minus 2, n minus 1, so 1. So just adding both of them. So it will be 1. This will also be 1. So here we will be summing up. We will be getting 2. So Fibonacci of 3, which we have already found 2. So here we also get 2 in this end. But 2 is for the portion, for the right side portion. So for this, we get 2 as answer. Now we will go to this one. So this will be 2. So for 2, what we have to do is we have to again do the same step because it is not in its base form, or we can say base case. So okay, it is 2. Here we will get 1. Here we will get 0. Adding both of them, we will get 1, and 1 plus 2 is equals to 3. Simple, solve. So now if we go here, you can see if input is 4, output we have to give it 3. So that's how all this whole problem is structured, or I have given you the dry run, like how we can solve this specific problem, Fibonacci of a number. Uh, so now I think you should have understood what is the approach, or how we can solve this problem in a dry run. But from the problem statement, while doing the dry run, you should understand that the problem which we have solved in this one step is repeatedly happening. Like what is that step? It is doing n minus 2 and n minus 1. We are doing this step repeatedly again and again. Okay, n is getting changed, but n minus 2, n minus 1 is similar. Same we will be, there is one more thing which is happening, which is check. You can say it is check for base case. And what is that base case? That base case is if our n reaches 1 or 0. Okay, so if we get that one step is repeatedly happening, you should get a understanding that recursion needs to be applied here, because a single step gets repeatedly happening, and so you have to apply recursion. And the base cases which we have is 0 and 1. Okay, so that's how this whole problem is just around these two numbers, but the word which has given to it, like Fibonacci number. So if someone doesn't know about Fibonacci number, he or she might get confused, like what is this? This might be a bigger problem, or this might be a very uh, difficult to solve. But in actual, it is very easy. You can see that we just have to do n minus 2, n minus 1, adding both of them and checking alongside, like, okay, if the base case happens again and again or not. So that's what we have to do. So if we have to start solving this, we can although solve this here also, but for the understanding purpose in the beginning, because I will be telling you how to solve it in LeetCode so that your profile on LeetCode will also get established. But here in the online CPP compiler, now let's solve this off. Uh, Firstly, taking an input named as n, taking Cin, just the input of that number, and now we have to find the Fibonacci of it. Uh, so as I have told you, we have to apply recursion here. So recursion is the thing which we have to apply. And so what we will be doing, we will be making a function outside of it. So what happens whenever you sit in a problem solving interview, what happens, most of the company work in microservice architecture. In simple words, I have to say, the program or the functionalities which is there in their application. Just take example of Flipkart. So if we have to take example of uh, adding product in our cart, then from product to doing payments, then for payments to delivery, all those are divided into subparts. Same we have to do here also in our, while solving a problem, instead of solving it in single code, divide the structure into different classes, functions and all. So that's what we will be doing here. If I name it as REC, because you can name it as anything, and then we will be taking the input as n only. So it is like we are having an int. Int is the thing which we have to return from this function, and int n is the input which we are getting. So now let's get into bit of the basics about recursion also. So what I want to say is, instead of every time solving a problem from the basic or scratch, like if I said recursion, if someone is thinking, oh, I don't know recursion, now I have to go back and learn about recursion, and then no, just see how it is implemented and then learn step by step by solving a problem only. While solving a problem, you can learn about it. So in recursion, firstly, we have to give a base case so that whenever we recursion is like, let me tell you in the this whiteboard only. So if I have recursion, so how it is done is, we will be calling a function. If a function name xyz, that function will be called again and again and again with a bit different inputs for sure till it reach the base case. If we didn't if we didn't give a base case, it will go for infinite and our program will it is not able to compile. It will give us error. So what will happen? We have to firstly think about the base case, the program, and that's all. Along with that, we have in this problem only we have to return again and again a same problem. Like we have to return this same function in this whole, we can say, a function. So it is just like function inside a function. How it will be done? Let's see. So just like taking this example only, name it as XYZ. Now, firstly, what I have told you, we have to give a base case. So what is base case in this whole problem which I have told? Base case is our uh, if our n reaches 1 or 0, then we stop doing it. Same here, it is written if we start from 0 and 1. So these are the base cases. Now, although I can write it like if our n equals to 0 or 1, then we have to return 1 and all. But there is one more way to do this. That is a bit of not interesting, just uh, this you can even skip the way and solve it with the normal ideology also, like if n equals to 1, then return 1 and else, or I can say else if only, else if, okay, n equals to 0, then return 0. Easy peasy. But let's understand bit of the things, like high level, not high level things. These are just just in order to make program bit more interesting. Return, instead of returning 1 or this, we'll be returning n. So if we get 1 as n, or if we get 0 as n, what will be happening is we will be returning that number only. If we get 1 or 0, that thing will be returned. And how a function executes is, or how this function also executes is, like if we have to structure out this specific function, if I will copy this and paste it here and then try to tell you. So what happens? Int xyz is the name of function. So what will be happening is, whenever we will return anything, whenever we return any number, 0, 1, 2, 3, whatever the number will return, this will get out of this function. This function will return value, and then this will not be executed. So that is the ideology about returning. So that's how it is done. Uh, but but still, we forgot, I think, anything. And what is that specific thing? That is, we have to also do one more addition to it. That is finding Fibonacci, doing n minus 2 and n minus 1. Now, uh, how to do that? That is the problem. But for that, just just uh, just applying the concepts. Don't go into the in-depth of recursion, like how it is going in the beginning only, how is tree happening. If we do this, like calling this function xyz and giving n minus 1 plus n xyz n minus 2, what would you think that what I have done till here? So this is where the recursion starts, calling the function which we have made again in this. So I will structure this out like how it will be working. Okay, but you just need to apply the concepts in beginning, like thinking about the logic, dry running it, finding out the method which we have to follow. If it is repeatedly happening again and again, apply recursion. Going here, doing C in, and then just doing C out of XYZ with this number. So now if we run this, let's see if we encounter any of the errors, then we will be solving them off. Yeah. So now let's give 3. We are getting 2. Okay. Let's give a Fibonacci of big numbers. Just to check how to find Fibonacci, 100 Fibonacci. It is very big. Leave it. Uh, so now let's just put the values only, like 4, which we have as Fibonacci. So it is working. Now we didn't went for that like thousands or something like that. But we are getting the number. We are getting the thing which we want. So Fibonacci number is called a sequence. So we have actually solved the problem. So now we will be doing it in LeetCode also, so that it will check for different test cases which we have. But firstly, let's do that and see what we will get. So I will just copy paste this so that you can understand. Okay, if this is the function which I have written here, how will it run in a LeetCode? Just pasting the thing which I have written there only. We didn't have to take input here, so I am just doing this, this, and this. Not see out, obviously. Return, because the function which they have given to us, int fib, we have to return int here also. So that's how it will be doing. Now, firstly, let's run this off and see if it is working or there are some issues. It is accepted. So for this 3, it is working. Now let's see if we submit this, it will run for more test cases. Let's see if it works or not. Yeah, it works. Okay, hopefully we got the answer. Okay, I will be sharing this link with you, uh, so you can also go through it and see how it's working. So now let's go into the bit of dry run of this problem, which I have told you. Uh, our motto is not to just solve problem and then go away. We have to understand the problem statement and then the solution also, like how it is actually working off. Now, what is happening if I have to, if if you are a like beginner also, you will understand what is this for sure. So we will not going among this. We will be just talking about this specific thing, how it is working on. So now, simple dry run of taking 4 as a number. Okay. Now let's get into our program. Condition. First one is the condition. This is the step 1, I can say, and this is the step 2. Step 1, check, check for the step 1. Is it passing that, or is it happening? No. Okay. It is not 1, it is not 0. The number we have n for sure. Okay, no problem. Now we go to if it doesn't happen, then this will happen because it is written on the top, return n. Okay, so if any case we will get 1 or 0 as n, we have to return from there. So we didn't return from there, so we get to the situation number 2, which what we have to do, we have to return again this function with an input of n minus 1. Okay, just think about it. Just think about this portion x, y, z, n minus 1 plus x, y, z, n minus 2. Now you will be thinking like, why this, there is plus written, so why you are not adding them first or doing something? No, just go into it. How we have written the problem. But it's n right here, 4, n right here, 4. But we will be getting actually, it means n, if I have to erase this, it will be n minus 1. N minus 1 is 3. It will be n minus 2, and n minus 2, as you know, it will be 2. Problem we have, get into it. The function, don't think about recursion right now. Just think it as an individual function only. But we have solved it now. Check for the statement or the condition. Uh, uh, Check for the condition 0 or 1. It is no. It doesn't match. So we again go to this return. So again we have to call this function xyz, in which n minus 1 plus xyz minus 2. Done. Now we will be solving out this portion and this portion simultaneously. Check for this function. This, take it as an individual function. Don't think about recursion and anything else. xyz with the value 2 with the end 2. Check for the condition if it is 0 or 1. If it is no, go here, go here, write another program xz2 minus 1 and xyz 2 minus 2. Okay, and then adding them also. So these are the two statements. Okay, now the function we have started off with is just xyz of 4. It divided, now we have actually four functions, four xyz functions. Get into it. Xyz of this, so it will be, I can like, can I write it as 2? It is easier, like 3 minus 1 is 2, 3 minus 2 is 1, 2 minus 1 is 1, and this is 0. Now again go to this function. Don't think about recursion and anything. Just think about the function. xyz of 2. Is it passing the condition? Is it passing? No, it is not. Get into it. Again do xyz of 2 minus 1 plus xyz of 2 minus 2. Okay, then don't think about it. Just write and forward. xyz of 1. Get into it. See if it is passing any of the condition. Yes, it is passing the condition. So our xyz of 1 is, it got caught in the condition of if n equals to 1 or n equals to 0. Then what we have to do? We have to return n. And what is n right here? It is 1. So it got caught in this condition. So we will just go till the step 1 only, and we will not proceed for step 2. So from here, we will be returning off the value. Now we were going in the downward direction. Now we will start returning of the value. So instead of xyz, what the value I will be returning of is 1, because I have written here na, return n means return whatever is written here 1. So it will wait here. It will wait for some time, or I can say it will wait here for this. Like we have written xyz of 3. So one value have returned, that is 1. Now we will go here. Is it passing the condition? Again, yes. So we will again return the value 1. Is it passing the condition xyz of 0? 0 is here. Yes, again. So here we will be returning of 0 as the value. Okay. So let's wind this section up. So 0 and 1 is the things which we get in return when we execute this function. So it will be 1 and 0, and what we are doing here is addition, adding. So xyz of 1 plus xyz of 0, we are getting this. So adding them off. So 1 is the thing which we are getting here. So we will write xyz of 2 as 1. Just forget it. Here we have 1 in the background. It is waiting, like, okay, something will be returned from here, then we can proceed. So xyz of 2, 2 minus 1, I can write it as 1. 2 minus 2, I can write it as 2. Now again, this also reach the base condition. So it will also return 1. It will also return 0. We have to do addition, add both of them, we will get 1. So 1 is the value which it got, 1 is the value which this also got. Now these both have got the value, like 2 and 1 have got the values 1 and 1. Now let's add them up, because there is addition only. Adding both of them, we will get 2. So we will returning 2 here at the hierarchy level. Okay. So what we can see from the functions only, while deriving both of the functions, we got 2 and we got 1. Okay, from both of the functions, like returning. Now the last return which we have to do, again it will be returned to the top. Again it will be returned to the top, where we have to do addition of both of them, and adding 2 plus 1 will give us 3. And that's how we will be getting the solution of it. And that's why if we run it like if 4 is the input, then 3 is the output. So that's how whole function is working. So instead of just thinking about it is recursion, I will not able to solve this, just break down the problem into simpler problems. What we have to do. Recursion is just only, if I have to give a brief about or the definition of recursion, it will not be like calling a function inside a function. That is like statement which you can write in your exam. But in actual, dividing problem into smaller problem, smaller problem. That's what recursion is. If you have a bigger problem, divide it into smaller problems, solve them off, wind up the answer, and get the answer. That's all. The dry run is in front of you. The code is in front of you. It is running in both of the compilers, or you can say where we have to do. So I have submitted it. So it got accepted also. So that's all. That's all what we have to do. It is done. So we have solved the question for our day one. So Fibonacci number is solved. From here, just solving the question is not the right way. I'm saying it again and again. Getting the approach, how to solve a problem is the right way. I have told you about the recursion in the most basic way or most basic possible way in which we can do it, dividing a problem into smaller problems. You might like cram this answer. You can just remember this answer. Okay, when Fibonacci number comes, we have to just apply this x, y, z, n minus 1, x, y, z, n minus 2, write the base condition and return it. We will get answer. But in actual, when you have to solve the problems in the upcoming lectures or the bigger problems, then you will face issue how recursion is working, how everything is working. At that time, if you dry run like this, okay, then you will be getting the answer like how it is working. So as I have said, instead of just thinking about recursion, just think about the function itself at that position xyz as one function. You got the answer. Yeah, that's how it happened. Whew. So I think we are done with our day two, or we can say day one of actual problem solving, day two for our series. So that's all. I hope you like it. So what I want in return is not the like, share, subscribe. What you can do is you can solve the problems along with me so that you will also practice a lot. You will also get a good GitHub profile, this LeetCode profile with you at the end of this series. So that's all, and that's all for this video. I will just say thanks for watching, and let's come tomorrow and solve another problem too. Bye.